Good morning, 5th grade math. We're going to be looking at lesson 13.2 today, which is continuing on our study of triangles and different kinds of triangles. Specifically today, we're going to be looking at the relationship between the angles of a triangle. We're going to be looking for any patterns. I'm going to start by showing you this triangle, which I did not draw to scale. We're going to talk about what that means in just a minute. But as you look at this, you can see two of the angles, and I'm asking you what the third one is. Now, now you may be thinking, I don't have enough information to find out what that one is. Hopefully you see it's an acute angle, but we're not sure what measure I would say for that if this is all we know. My hope is by the end of this lesson, you'll be able to confidently say a method so we can find out the exact measure of that angle. But to do that, we're actually first going to look at some triangles we've used in previous classes. Ooh, turn off that glare. There we go. These are all triangles that I've used in previous lessons and I've cut out of those papers. If you would like to make your own triangles, you're free to do that too for this exercise, and it will be helpful in seeing the relationship between angles. Let's look at this one first. What kind of triangle is this? A little review from last class. You can see a right angle makes it a right triangle. These two sides, I'll tell you, are equal to each other. So what kind of triangle does that make it? If you're thinking right isosceles, you would be correct. What I'm going to do now is I'm going to use these scissors and I'm going to cut this triangle up so that each of these angles is unattached to each other. The reason I shaded them in green is that after I cut them up, I can still tell which part of each piece is the original angle. So I'm going to cut them in kind of weird curves. Alright, I now have 4 different pieces. This is the middle piece, I don't care about that one. But these 3 are the 3 angles that made up that right isosceles triangle. I'm trying to arrange them in some way. What if they were all next to each other? Ooh, what does that look like? Something that we've already studied. Zoom in a little bit. Does anyone recognize a concept or a term for that? Let me move that one up and do the same thing with another triangle. So that was a right isosceles. What kind of triangle is this? If you're thinking obtuse, you'd be correct because there is an obtuse angle. Remember, triangles have to have at least 2 acute angles. And then the other one can be acute, obtuse, or right, as they were in this one. This one is at least obtuse. It may be isosceles, but it's a little bit hard to tell. Alright, let's cut that up in the same way. I want to focus on the angles. There are my 3 angles. So let's get rid of that extra piece and arrange all of these together again. Ooh, those look similar to the other one. The term I was thinking of, I don't know if you were thinking it, or angles on a line. All 3 of those add up to be 180 degrees. Let's try with just 2 more quickly. What kind of triangle is this? This is an equilateral triangle because all 3 sides are equal, and it's also acute. All 3 angles are acute. Let's see if it works for that kind of a triangle. Alright, get rid of the middle piece. All 3 angles. Yep, they make an angle on a line. And then finally this one, which is scalene because all 3 sides are different, but is a right triangle. It's got a right angle. So at this point we've looked at obtuse, right, and acute, and we've looked at scalene, isosceles, and equilateral. So all 3 different types of triangles. And if I measure this up, look at that. Once again, they end up being angles on a line. What that should tell us is that in any triangle, all 3 angles have a sum of 180 degrees. And let's test that out again just by drawing a triangle of our own. And if If you haven't yet, I'd encourage you to actually try this. Any kind of triangle you want. I'd make it big enough so you don't necessarily have to cut it out. You can just use a protractor to measure it. But if you would like to cut it out, that's a fun thing to do too. So I'd encourage you to do either one of those, whatever helps you learn the most. I'm going to draw kind of a weird type of triangle to really test if this works. Let me finish this point. I can still measure it actually. But as you can see, this one has two very long sides and one that's quite short. This does look like it's almost exactly at a right angle. We'll see in just a minute. Alright, I'm going to start off by measuring that point right there. So line that up. It looks like that is exactly 90 degrees. So this point right here is 90. Which means that this is a right triangle and the other two should be acute. And this one definitely is acute. And let's see how acute it is. It's almost exactly 10 degrees. And then this angle down here is exactly 80 degrees. So the numbers worked out really nice on that one. They're all multiples of 10. 10 plus 80 plus 90, 180. So I just drew a random triangle, and it ended up working with our new theory that all three angles have a sum of 180 degrees. Now let's go to back to that original triangle, the very beginning of this lesson. This is 46 degrees, this is 93, and the question is how much this is. We should actually have a way of figuring this out now. Just like we would on angles on a point, or angles on a line. That means 180 degrees is equal to 46 degrees plus 93 degrees plus that question mark angle. 46 and 93 together are 139 degrees. Means 180 degrees equals 139 plus question mark. Subtract 139 from both sides, and I'm left with 41 degrees is equal to the question mark. Now, does that make sense looking at this triangle? Yeah, these are almost the same size, and this is acute. So yes, 41 degrees would make sense. And that brings a little bit more proof to our new theory, that all three angles of a triangle added up equal 180 degrees. Now, one other thing that's really worth noting as you go into this homework. Not drawn to scale. And we've briefly talked about that before. But what not drawn to scale means is that if actually this triangle right here, I just drew three lines and I threw a number at it. I said, well, that's about 46 degrees. That's about 93. For the purpose of making problems, sometimes I and sometimes your book will not take the time to actually measure out the exact right size. We'll always make it close. For instance, this is an obtuse angle and this is acute, so it's close. But if I used a protractor to measure this, I would see that this is actually a little bit less than 40 degrees. So if I tried to do a little shortcut and just use a protractor instead of doing the math to figure this out, I would get an incorrect answer for this angle. So if it says not drawn to scale, what that means is if you use a protractor to try to find your answer, you're going to get the wrong answer. So when it says not drawn to scale, you have to use the math. 180 minus 46 minus 93 is after the question mark. Alright, 5th grade, you shouldn't necessarily need a protractor then for your homework pages, and there's not a lot of them, workbook pages for you to look at anyway. It's just pages 123 to 124. Make sure to watch my video about some of the harder homework problems, and bring any questions you have to our Zoom session tomorrow. Thank you.